In this review, we'll take a look at some electric circuit basics. An electric circuit is a place where charges can be given energy, and then that energy can be dissipated to do something. In this case, we have a simple battery hooked up to a simple light bulb. Notice a few things that's happening here. Number one, the battery is what's providing energy to the charges so they can move through the circuit. Number two, charges are moving at all places in the circuit itself. Notice that no electrons or no charges are disappearing in this circuit. The last thing to notice is that the charges, when they have energy, can do something useful. In this case, they're dissipating their energy here in the light bulb as light and probably heat. The three concepts that are involved then are voltage, current, and resistance. All electric circuits have all three properties. Let's take a look at what they mean. The first is voltage. The voltage in the circuit is provided by the battery. What the battery does is it gives each of the charges that pass through it some energy. Those charges can then go somewhere else and do something useful. A 9-volt battery provides 9 volts of electric potential or voltage to each unit charge that passes through it. Right. A 1.5 volt battery would do a little bit less than the 9 volts. The next concept is current. Current talks about the rate at which those charges move through the circuit. Here you can see the current is relatively low. Charges are not moving all that quickly, or better yet, there's not a lot of charge that's moving through this circuit. What's interesting here too as well is the fact that since there's only one pathway for the charges in the circuit, there's only one value for the current at any point, and that value is the same. If you look at the charges that come out of the battery, that go into the switch, that go into the light bulb, that come out of the light bulb, that go back into the battery, the rate of that charge flow is always the same, and therefore the current in the circuit is always the same. The last concept is that of resistance. Resistance talks about how difficult it is for the charges to pass through a portion of the circuit. In this case, a good question would be why this wire here is the wire that actually gets hot and emits light. After all, that's just made of metal just like the rest of the circuit. However, what's different about this value here is that the resistance of the light bulb is actually fairly high. Wires do not have much resistance, and so also the battery doesn't have much resistance. So it's in this case here, where the light bulb is located, that energy that was given to the charges by the battery actually becomes or gets dissipated and it gets emitted as light and heat.